Good afternoon, because that's when I'm recording this. This video is for Algebra 1, Chapter 10, Lesson 5, the last lesson of the chapter, graphing square root functions. A square root function contains an independent variable in the radicand, kind of like that. In this case, the independent variable is x, the dependent variable is y, and the simplest square root function looks like this, y equals the square root of x. When x is not a perfect square, approximate the y value to the nearest tenth. Remember that value of the radicand cannot be negative. Therefore, the domain is limited to those values of x that make the radicand greater than or equal to 0. To find the range, use the least value possible in the domain and then several other values, and this will allow you to figure out where the range bottoms out. All right, so how do we actually do this? Well, we're going to start out with a problem like this one, y equals the square root of x plus 3, and we're going to figure out the domain. Again, the stuff inside the domain has to equal 0 or be greater than 0. So, this is how we're going to do it. We're going to set what's inside the radicand, and we're going to set it equal to or greater than 0. All right? So, then we're going to basically solve for x. So we're going to minus 3 on both sides, and we're going to figure out that the domain is x when x is greater than or equal to 3. And that's how you write your answer. So make sure that you're writing it correctly in that yellow box right there. All right, so now that we know the domain, we can figure out which possible values we can put in for the range. So I'm going to go ahead and make a table. And I'm going to plug in the values. Oh, let's see it. Let's see that beautiful table make itself. There we go. Okay, so we know that we can stick in numbers that are greater than or equal to 3 into this table to help me figure out what the range is. So I'm going to use -3, -2, -1, and 0, and then I'm going to plug each of them in to x and figure out what my y is. So the square root of 0 is 0, because -3 plus 3 is 0, square root of 0 is 0. All right, so when I plug in -3, I get 0 out. What happens when I plug in -2? Well, I get the square root of 1 out, which is just 1. If I plug in -1, I get the square root of 2 out, which is just 1, -1, and 1.4. Now, if I plug in 0, I'm going to get the square root of 3, which is 1.7. All right, so that is the answers. Now, if you'll notice, all of those ranges, all of the y values, start at 0 and only get bigger, which means we can write the range as numbers that are greater than or equal to 0. So those are my 3 answers. All right, and again, you can plug in whole numbers right here as long as they are your domain or bigger. Well, your domain and bigger. All right, I could have probably done like -3 and then 0, 1, 2, and 3, but again, doing just a few numbers, consecutive numbers after where your domain starts is good. All right, next one. Alrighty, so let's go ahead and do this problem. I'm going to figure out the domain by looking at what numbers are greater than or equal to 0 as far as the radicand is concerned. Solve for x. X is greater than or equal to 4, which means the domain can be numbers 4 or greater. Then I'm going to make a table, and I'm going to figure out some points. I'm going to plug in 4, 5, 6, and 7, because you can have to be numbers greater than or equal to the domain. And I'm going to plug them in and keep going. And those are my answers. And then you'll notice the domain starts at -3 and goes up. So that's how you figure out the domain and range. Alrighty. So, actually graphing these, well, you're going to graph them the exact same way that you just plotted them, and you're just going to plot the points and connect the dots. And we're also going to talk about how, you can kind of tell where things are going to start and stop just from looking at it, and then so that you can ensure that you're graphing your table correctly. So let's go ahead and figure out the domain, same way we did before. So the domain is x plus 4 is greater than or equal to 0. So that means x has to be greater than or equal to 4. So then that's what I know my domain is. I'm going to make my table and do some math. And then I'm going to plug in numbers that are equal to my domain and greater. So it'd be -4, -3, -2, and I'll end up doing -1 too. Don't worry, I didn't forget about it, okay? All right, and so yeah, I didn't forget about -1, so we'll do it in a second. All right, so let's plug in -4. I get -4 plus 4 equals 0. The square root of 0 is 0. And there's the point. Then I plug in -3, and -3 plus 4 is 1. The square root of 1 is 1, which is that point right there. And, excuse me, the bell's ringing. And then I'm going to plug in -2 into my square root and get the square root of 2, which is 1.4. So that would be -2, 1, 4, which is right there. And then I'm going to plug in 0 I get the square root of 4, which is 2, which is right there, and just for keepsakes, -1, and it gives me -1 and 1/7. And then connect the dots. Beautiful. All right, I'm going to pause real quick because I have people coming to my classroom. So there we go. So as you can tell, where the graph starts is, oh, and this is the range. Sorry, I had to pick up from where I left off. This is the range, and you can see that, actually the range is not -4, Miss DH. The range is 0. The range is 0 because it is the smallest number that would be the y, or the f of x. There we go. And you can tell that because it starts at 0 on the y-axis. All right, so let's go ahead and do the next one. Oh, and there we go. So that's the opposite direction. So notice how the +4 is inside the radicand, and then the fact that the graph starts at -4, so it's the opposite direction from where it's going to start on the x-axis. All right, so let's go ahead and do another one. We have f of x is equal to x squared plus 1, where the plus 1 is not inside the radicand, and that might change some stuff. So go ahead and do the domain. Go ahead and figure out what domains you could use. That would be like 0, plus 1, plus 2, plus 3. Plug them in, graph some points. Plug them in, graph some points. We're almost there, almost done. There are the points. Now, the range, well, the range was 1. There we go, or greater than 1. y is equal to, greater than or equal to 1. And then, let's notice how when we have a plus 1 outside of the radicand, it means that we're going to go up 1 on the y-axis. So this is the whole slide thing. Inside the radical goes opposite directions, left and right, and if it's outside the radical, it goes the same direction, up and down. All right, so last of the slides, and we're only at 7 minutes. This is amazing. Application. In good weather conditions, police can use the formula below to find the approximate speed, r, of a car that leaves a skid mark of a length, L, in feet. So graph the function. So again, we can figure out the speed of a car based on the length of skid mark it left before the brakes were applied. So let's go ahead and figure out the domain, same way we were doing it before. Oh, actually anything greater 0 or equal to. Now obviously if a car isn't moving, it's not going to leave any skid marks. So the speed of the car was 0 if it left no skid marks. At 10 miles per hour though, it's going to leave 14.1 foot skid mark. If it was leaving a 10-foot skid mark, the car was traveling at 14.1 miles per hour. If it left a 20-foot skid mark, it was traveling at 20 miles per hour. If it left a 30-foot skid mark, it was traveling at 24.5 miles per hour. And if it left a 40-foot skid mark, it was traveling at 28.3 miles per hour. So if we go ahead and graph this, where the x is the length of the skid and the y is the speed of the car before the brakes were applied in miles per hour, we can go ahead and graph these points. So 0, 0, there we go. There we go, there we go, there we go. Now, last question. How long will the skid mark be if the car braked at 85 miles per hour? Well, we can do some quick math where r is 85. Divide 2 on both sides, square on both sides, divide by 5 on both sides, and we figure out that the length of the skid mark would be 361.25 feet if the car braked at 58 miles per hour. So that's why you should definitely make sure you drive a little slower, because if at 85 miles per hour you're leaving a 361.25 feet skid mark, that means that's how many feet it took you to stop from when you hit the brakes to when you actually came to a complete stop in your car. And very few people drive with 381.25 feet between them and their car, even when they're driving 85 miles per hour. So please make sure you have enough room to stop, and that is your first driving lesson tip before most of you actually even go to driver's school or even get behind most wheels. All right, I'm done. Bye, guys.